Hi class, today's lesson is lesson 2-7. It's about solving multiplication equations. Let's go ahead and take a look at the purpose. The purpose is to solve whole number multiplication problems algebraically. And again, that's the most important part in the past couple lessons, and the next couple is the algebra involved in solving those problems. There's no new vocabulary. I think you'll find this lesson will fit in like a hand in glove with the other two just prior to this one. Here we have our first example. It asks us to solve each equation and then check your answers. First problem we have is 3x equals 12. Now, like the addition and subtraction problems, we're going to go ahead and draw a scale right underneath there to indicate that an equation is really a balancing act. We have 3x on one side and 12 on the other. So just like the other two types of equations, we're going to try to isolate the variable. But how do we get rid of a 3 times x? How do we get rid of the times 3? Well, in order to get rid of a times 3, we're going to divide by 3. And what we do to one side, of course, this is a balance, we've got to do to the other side. When we divide by 3, 3 divided by 3 on this side means it's equal to 1. 1 times x is just a plain 1. That's my thought bubble. That's my mental math right here. 1 times x. 3 divided by 3 is 1, and 1 times the x over here is just a plain x. So what we have left is an x on this side. 12 divided by 3, of course, is 4. Now, again, the solution is very easy to come up with. You can do this mentally, but it's the algebra involved. Isolating the variable, using the inverse operation of multiplication, 3 divided by 3, and then doing to both sides of the equation. With the second example, we just have the variable switched around on the right side instead of the left. That's all. We do the same thing. We go ahead and draw a scale with a fulcrum underneath the equal sign, again indicating the balance between the 8 and the 4 times w on the other side. We always want to isolate the variable in order to solve for w. So in order to isolate the variable, we've got to get rid of this times 4. How do we get rid of the times 4? Well, once again, we divide by 4. And if we divide by 4 on one side, we've got to divide by 4 on the other side to keep this scale in balance, to keep this equation in balance. 4 divided by 4 is 1, and 1 times w. Oh, that looks like a weird W, but believe me, it's a W. 1 times W just leaves a W on this end. The equal sign is placed right underneath the other equal sign, and then 8 divided by 4 is 2, so 2 equals W. Now, we've got a problem-solving application. And here's the problem. The area of a rectangle is 36 square inches. Its length is 9 inches. What is its width? So we're going to take these problems one step at a time. First of all, we've got to understand the problem. Understanding the problem means, what are they asking for? Well, they're dealing with area here. The area of a rectangle they've given us. Its length they've given us. What they want to know is its width. Okay, so I understand the problem, and I'm going to write down, as part of understanding the problem, the data which they give to me. I'm going to put down an area of the rectangle equals 36. Okay, and the length, I'm going to make that an L, is equal to 9 inches. What they want to know is, what is the width? So I'm going to put a question mark. Notice I didn't put labels on it. I'll put labels on in the end. This is just working through the problem. You don't need labels unless you want to. So there is what I understand of the problem and the data associated with that problem. Next, I've got to make a plan. First of all, I guess in order to make a plan, I want to make sure that I understand this problem. So I'm going to draw a rectangle. And since there's 36 square inches in the middle, and the length is 9, I've got to figure out this width. Okay? It looks like, and if I remember from my experience with rectangles, that if I multiply this length times the width, it should give me the area of the rectangle. So my plan is to plug this into the formula. Area equals length times width. That means 36 would equal 36 inches squared. Right there, the area would equal the length, and the length we've determined is 9. 9 times W. We'll just call this width W. Okay. Now, I'm going to go ahead and just simply solve this problem. The way we do that, of course, I'm going to draw that scale. How do we isolate the variable? Well, we've got to get rid of the times 9. How do we get rid of the times 9? Inverse operation, which means divide by 9. We're going to do it to both sides, dividing by 9 by both sides. 9 divided by 9 is 1. 1 times W is just a plain W. 36 divided by 9 is 4. So the answer is 4 inches is the width. Now, we have to look back. That's the fourth part of this, is we got to look back now. Does this fit? Well, let's plug it into the equation. Length times width should equal the area. So we substitute a 9 times a 4. 9 times 4 is 36. Does 36 equal our area? Absolutely. So this is the solution. Next, you're going to be tasked with these two problems. Once again, I'm going to make you draw the scales, just so you get, once again, get the idea that an equation is just a balance. And then solve. We'll see you in class.